Welcome to, I guess, the last video on relations with respect to the content for any grade 9 student. And in this video, I guess it's the content video in terms of what we'll be covering in this video is linear and non-linear graphs. So just being able to see, so if somebody, for example, gives you or you yourself plot a scatter plot or a scatter graph, you find kind of the best fit lines that fit that particular data, and then you should be able to gauge if the graph is linear or non-linear. Okay, so this is just in 2 dimensions. So we just have independent and the dependent variable on the x and then on the y. And I'll talk about a few things, and in terms of giving you some examples of both linear and non-linear examples and what can happen and how to actually spot them. And with that, a nice application of these linear and non-linear, especially for someone who wants to get some intuition, and that is kind of distance time graphs. So we all have a pretty good visualization of covering a distance, okay, so whatever it may be. And then as time goes on, we can cover more or less, and we can come back. And I'll give you some examples of some of those graphs, and then we'll try to interpret those graphs. And keeping in mind that all of these nice, beautiful lines that we typically see both in math and science, especially in school, they're kind of fake because they're coming from the real data, which is really the scatter plots that you see. Okay, so you see them, 2 of them on the screen, and clearly it's they don't look like lines at all, right? So they have a bunch of plots in terms of points, and then we try to fit the best line. So when you are watching and seeing an actual graph, which is a nice, beautiful straight line or some other maybe non-linear line, remember that it is coming from data, which is unfortunately most of the time forgotten and not always communicated to students. If something looks really pretty in terms of a graph, more often than not it's fake, okay, or it is some kind of an approximation. All right, now those approximations are actually really good because we can study them and we can do quite a bit of information. So they're not useless because they give us some information. So what are these linear and non-linear graphs? So if you take a look on the screen at the moment, and so as I said, so we have, so you can imagine, okay, so our x-axis, so here this is our independent variable, and then here, okay, on the y-axis we have our dependent variable. Now from whatever data this is coming from, it actually is irrelevant at the point, because I just want to show you how we can interpret these linear and non-linear graphs. So if someone asked you to do a best fit line for these particular scatter plots, so I'm going to give it a shot here. All right, so let's pick green here, and I'm going to try to draw a line. And in this one on the left hand side, so this one actually fits very nicely. I can kind of draw a line which goes kind of in here, and that particular line kind of is our best fit line. You can of course change it ever so slightly if you really wanted to make it a little bit more in terms of fitting the actual scatter points. Now the one on the right hand side, we can't really fit a line here. So if we wanted to fit a line, I mean, if we do something like this, which sometimes students will want to do, it's not really a great fit here. Okay, so this one doesn't really work. You can try to do maybe something like that. Again, that one really doesn't work because it kind of really pushes away from those top points there. So that one doesn't work. So really, I mean, if I was drawing this, I was kind of going to go like this. Of course, now this little bit of magic here. Let me try to see if the... okay, so if it picks it up, okay, so perfect. It picks up that curve there. And that's a little bit more likely, okay, in terms of trying to fit a line through this. So it turns out that this scatter plot on the left hand side, so this one is definitely looking like it is linear, Okay, and if you wanted to know, so the easiest way in 2 dimensions as you have it is basically if you can fit a nice line into your scatter points, okay, that is considered linear. Okay, so it is following nice lines, and I'll give you some examples. It's just literally a straight line that you can approximate the scatter points from the experiment that you conducted. Now, when it is not a straight line, then we basically call this nonlinear. So this would become nonlinear. And there are obviously way more examples of nonlinear than linear, because a line you can only draw a certain way. Now, of course, those lines can kind of rise up faster and slower and go in reverse or be flat. But in terms of nonlinear, we can do all kinds of magic in terms of drawing an actual line. All right. So again, linear just simply means that you can nicely have a straight line on the graph, and nonlinear is basically pretty much anything else, right? That is not a straight line. So those are the 2 scatter points. So here just below, I'm going to give you some examples in terms of drawing these lines, and they can be anywhere. So they can kind of start anywhere. This will depend on the data that you have. So for example, you know, if I draw a line here, so this would be, okay, a straight line, right? So this becomes linear. I can do a different line. Let me just kind of change the color. So the lines can also come straight down. So for example, something like this. Okay, so this would also be linear that we have. Now those lines in terms of linear, they can be also flat, right? So for example, you know, this one might be flat, okay, like this. And all that data would be telling us. Now, we don't know what we're exactly measuring here. I'm just drawing them out. I'm just trying to show you examples of linear and non-linear, right? So they can be rising up, they can be rising down, they can be flat. They don't have to be, okay, as steep. So they can be rising very slowly. You know, so for instance, something like this, you know, it doesn't exactly look like it's rising too fast, but it's still linear. So something like that. Now, they can go on forever as well. And if we do typically want them to go on forever, you know, we would kind of draw a little arrow, okay, that is pointing that it's actually going in those directions. They can also go in the opposite direction, okay, so that will depend on whatever data that we have. But if this was, for example, with respect to time, and time started at some point 0, then we would be drawing these. Now, for nonlinear, well, this is a lot more exciting because we can do wonderful magic with nonlinear, right? So in terms of nonlinear information, so anything that is not a straight line, so we've already seen one, okay, which was kind of looked like this, like it's kind of sloping down, so that would be definitely nonlinear. Now, they don't have to be necessarily just lines in this direction, okay, so this, okay, is actually a nonlinear one as well. Okay, so this kind of looks like a little bit of a parabola, as you'd be learning later on in school. So that's definitely nonlinear. Okay, it's not a straight line. You know, in the real world, we have wonderful magic lines that, you know, they can go kind of like this even. Okay, so that can be something of a nonlinear line. So these are numerous examples that we can see. And again, what I want the students to know, okay, when you're watching these wonderful lines are actually coming from real points. And most likely, you know, let's kind of erase this and don't forget, okay, so if I erase these two, you know, and you would be drawing your scatter points, there would kind of probably be something, okay, of this nature that, you know, you would have scatter points kind of going along, okay, kind of here. And then you'd be trying to fit, okay, a line that fits these scatter points, okay, so because they're coming from some experiment. And again, I'm just kind of making this up, okay, but this is what that would be, and that's what you would have, right? So you would have maybe something of that nature. And then so here, if I kind of erase this line there, so notice that that's what it would look like, right, in reality. But okay, you know, we draw these little lines so that we can study them, and then visually they look a little bit more attractive. And the same thing happens with the lines that are actually linear, right? So if I go back to that original one, And here, and I remove that actual line, so don't forget that this was actually just a bunch of scatter points that we fitted into a line that we had. And that's what you have to know, that these beautiful lines are actually not true lines if they're coming from experiments. All right, so that's linear and nonlinear, so hopefully that makes sense to you. Now, in terms of some distance time graphs, I really enjoy trying to encapsulate, okay, what is happening with distance and time. So what I would want you to imagine, because it's always kind of useful, so if you imagine that you had, let's say this was the ground, right? And this, so this is the ground right here, and then we have, imagine me, the stick man right here. Okay, so let's put some glasses on this, and a little smile there. That's a funny one. All right. Okay, so, and what you would have is, you can imagine that, you know, this would be your starting point. So this would be distance of 0. Okay, so let's say this is the distance that I would be walking, and or running, or being in a car or something like that. And then I'm moving in this direction, and then I can also go back in this direction. All right. So if you're drawing these distance time graphs, basically what you're showing is on the vertical. Okay, so this is our dependent variable right here. So what you have is your distance is always kind of on the vertical. And then right here, what you have on the horizontal, this would be your time. So with respect to time, what is happening? How much distance are you covering? And this could be in meters and centimeters. If it's walking, it's probably meters or maybe feet or something like that. And you can kind of see, all right, so where were you exactly at certain points in time? All right. So for instance, okay, if you were walking and I was drawing this out in reality, okay, so let's imagine, you know, kind of walking nicely and uniformly like this. All right. Okay. And then, okay, I kind of, I'm stuck here a little bit. Okay. And then it goes this way, and then maybe it goes like that. All right, so I'm putting these plots, these scatter plots. So this one, you know, if you look at it, you would say, oh, this is kind of nonlinear, which is true if we wanted to graph it, right? Maybe you would have been approximating it kind of like this, that you would be like going, oh, it's kind of like that. So that's what you would have. But we can approximate it also with some nice linear lines, and that would be, so for instance, we could connect all of these in a nice straight line. Then let me just change the color here so that it pops a little bit, and then we can connect all of these in a nice straight line. Then we can connect these in a nice straight line, and then finally we can connect these ones in a nice straight line. And there's some meaning here. So if you kind of go back to me walking along, right, that's what you see there. So you notice that basically I am covering more and more distance. So here, okay, I am kind of increasing, okay, so my distance, okay, so because the distance is actually growing right here, so that's what I have there. And that's the blue, and I'm kind of uniformly walking. And then I'm kind of stuck here. So on that pink, okay, so here on the pink right here, I'm basically not moving. So if this was me, and what would happen to me as I would be moving along, so let me kind of borrow this, okay? And so first, you know, I get to a certain point, so I walk along, so that would be that blue, and then I'm just standing there, right? Okay, as time goes on, so notice that from this period in time, so from right here to basically right here, I am just stuck in that one spot, okay, in terms of distance. And then notice that my distance, okay, I'm kind of going back, right? So I am returning back, and that's the green that I have. And so that would be, so this right here. So then I kind of take a few steps back. All right, so that would be the green, because notice that the distance is coming down. And then again, I am stuck there for the remainder. And then what happens after, I don't know, because that's when I stop. And that was the kind of brown right here, okay, and then I'm stuck kind of in that one spot, okay? So these distance time graphs, they nicely show us what is happening to the distance with respect to time. And it's always nice to visualize, you know, so the way that I would see it is the blue is, okay, I'm kind of moving forward, and then I'm stuck, I'm basically stopped, and then I kind of go back, okay, and then I stay there for a little bit. So that's what happens. And now, if, for instance, you know, these graphs that I have, okay, and let's say that, you know, I'm going to do a very fast one here like that, what that would mean is, notice that this didn't take very much time for us. So, you know, very quickly right here, I covered quite a lot of distance, right? I went all the way so fast, okay, to basically whatever distance that would be there. And so that means, you know, the steeper that line is, you know, that means that you're just very quickly, you're very fast, right? So your velocity or your speed is very, very fast. Now, if you had someone else walking along and maybe they weren't as fast as you, right? And it would take them a long time. Okay, so let's say, you know, that. So here, so what you would have is, so this person is not walking very fast, right? Because they only covered, okay, if I go back here, so they really covered only that much distance, so not very little. So they're kind of trotting along, right? So the steepness of these lines actually tell us how quickly we're covering distance. And when the lines are flat, then we're basically stuck, right? We're just stuck in that one position. And then when the lines are coming down, at least for this distance, right, that means we're kind of going backwards. So that's what you would have there. All right. So now here, let me show you. Okay, so this is kind of a nice example, and it's very non-linear, but this is very realistic. You can think of it and you can imagine it. What I would want you to do is imagine you have, so this is a little bit of physics, you know, you have kind of like a ball or something like that, or like, you know, I'm going to take this little, my toy car here. So if you take this, right, let's say this is at the distance 0, and then I'm going to throw it right up, right? So I'm going to throw it up, and then it comes straight down. Now, there is a point where it basically has to stop as you're throwing it up. Okay, it stops there for just a little bit, and then it starts coming down again, right? And then I caught it back at 0. So if you imagine that, you know, and you wanted to plot this, so, you know, this is a very nice graph because, okay, so let's say imagine that we're starting at 0 right here. So that was me holding the toy car, and then I throw it up. So I give it a force, and then it goes basically up, right? So it will reach a certain distance in a certain amount of time, okay, stop, and then it's going to cover, okay, and come right down. And that's where those nice parabolas come from, okay? So basically, so this point right here, okay, and if I do that, okay, so let me nicely jot it down here. So if that point right there, okay, so what that would be, okay, is this point, okay, was where that toy car basically stopped, right? So initially it was speeding up and going up, and then notice what's happening to this curve, okay, as you're going through. So it's going very fast up, and then it's slowing down, right? Slowing down, stops, and then it starts coming back down, back to 0, okay, and that's this second portion. All right, so that's this one, okay, and then it comes down, and then I caught it. So that's kind of another nice distance time graph that we would have. And you have all of these distance time graphs, and as you keep studying, you know, you might run into them in physics, definitely will run into it in engineering maybe, and that's my background as well. And it's kind of fun to be able to see these, right, in terms of the distance time graphs. Okay, so, you know, I'll do, okay, so one more here. Okay, if you have another one, and maybe I will use kind of highlighters so it kind of looks nicely. And so here, if you had something like this, okay, like that, and then that, in terms of a distance time graph, and we wanted to analyze this, right? What is actually happening. Okay, and let's imagine, let me redo this again, kind of so that we can nicely capture it. Let's say it goes something like that, and then it flattens out. All right, so what this would mean in terms of distance time, so you are starting off, so you started here at 0, all right, okay, so that's your 0. Then you quickly are moving away, okay, so you're going kind of forward in this direction, so that would be right all the way up to here, up to this point. And here you're basically stopped, kind of like that car, right, going up, stops, and then starts coming down. Okay, so here you would be, so the second portion that you would have, so this one right here is, okay, so you're basically coming down, and again you stop, right? So for whatever reason, you kind of are going up, maybe it was like on a sling or something, okay, you slung back, you stopped, and you came down, and it looks like, oh, you didn't reach all the way to the bottom here, right? You didn't reach all the way back to your regular place, and then it just slings you back up again, so that here, okay, you're once again going up, and then you stop, right? And then now again you start coming down, and then you stop, literally, okay? Notice that it flatlines here, so okay, at some distance, whatever this would be, let's say this was 1, 2, this would be 3, okay? So let's say if it was 3 meters, and then it just kind of stopped. Maybe it was like that car was being caught, and it was, not exactly at flat at 0, but it was caught a little bit above. So these distance time graphs are wonderful to see, and notice that if you wanted to see which ones were linear, which ones were not, so clearly, you should be able to say that this was nonlinear, right? That we had, this was also nonlinear, okay, in terms of the actual graph. So these ones were very linear, these ones were just straight lines. And this one, the first one, was actually a combination of linear ones. So you had one linear graph, second one, third one, and fourth one. And so that's what you would have in terms of, so those 4 lines would be linear because they're just straight lines. As a whole together, if you were analyzing the whole thing, then it's not linear because you would be graphing it out, and it would kind of look like a parabola up, and then it would just kind of flatten out. That's what you would have. All right, so again, in terms of reviewing, remember that all of these, which is what I really want you to take out from the video, is that these beautiful lines are always coming from some experiment, so they don't exactly look so beautiful. If you would be actually experimenting, remember that they're kind of coming from these scatter plots that we have, and then we pick and draw the lines in. All right. Okay, so we'll watch, hopefully you will watch a future video and test yourself on all of these relations. I will work on that and then post it up so that you can see if you can do a relations test. Okay, I'll do a lot of different questions there to see how well you understand all the different topics, from scatter plots, doing bar graphs, taking information out of them, primary, secondary data, different types of sampling that you do so that you can do these types of graphs, right? So kind of bringing everything together, talk about hypotheses and stuff like that. All right. Okay. Thanks for watching. Cheers. Bye.